This video focuses on the p-value and decision-making. The p-value is one of the most common statistical terms reported in the scientific literature, but also one of the least well understood. Researchers studying the effect of a corticosteroid on bleaching-induced tooth sensitivity found a statistically significant whitening effect for both treatment groups, which means that they rejected the null hypothesis of no color change after bleaching. They found no statistically significant effect of corticosteroid on tooth sensitivity, so the null hypothesis of no difference in tooth sensitivity between the two groups was not rejected. They found similar results for the intensity of tooth sensitivity, no statistically significant difference between groups. The researchers reported p-values, which provide the statistical support for their findings. Let's look at what these numbers mean. These researchers believe that orthodontic wires ligated with elastic modules will result in greater plaque accumulation than those using self-ligating brackets. And they're going to do a study to test this hypothesis. The null hypothesis states that there is no difference in mean plaque index between the two treatment conditions, and the research hypothesis states that the mean will be higher for the elastic module condition. This is the distribution of all possible sample mean differences when the null hypothesis is true. They have already set their significance level at the conventional value of 0.05. The researchers collect their data, which consist of a mean modified plaque index score for each patient in the study, and then conduct a statistical test that compares these means. This test result will be compared to the distribution representing all possible test results under the null hypothesis. The p-value is defined as the probability of getting results similar to those of the researchers when the null hypothesis is true. Suppose that the researchers find a mean difference at this point along the distribution. It is above 0, which indicates that the sample mean plaque index for the elastic module group was higher than for the self-ligating bracket group. The p-value is calculated as the probability of getting a result at least as extreme as these results, so it will always be the area from the test result through the tail of the distribution. This area represents 15% of the distribution, so the p-value is 0.15. By setting the significance level at 0.05, the researchers created a decision rule. Any result that can happen less than 5% by chance, that is, when the null hypothesis is true, will be considered evidence against it. A p-value of 0.15 means that there's a 15% chance of getting such results when the null hypothesis is true. The researchers would not reject the null hypothesis. These results are not statistically significant. We can also see that the mean difference is not in the rejection region, a further indication that the researchers would not reject the null hypothesis. The results do not support the research hypothesis, so the researchers would state that there is no statistically significant difference in plaque accumulation between the two conditions. The area for the p-value goes through the upper tail only, and not the lower tail, because the research hypothesis is one-tailed. That is, the researchers expect mean plaque scores to be higher for the elastic module group, so they are looking for differences only in the upper tail. This means that even if they had obtained a mean difference way down in the lower tail, they would not have rejected the null hypothesis, because the p-value is the area from the test result through the upper tail. The question is, how likely is it to get a mean difference at least as large as this? A p-value of 0.97 indicates that it is very likely. The p-value exceeds the significance level, so the null hypothesis is not rejected. The results do not support the research hypothesis, so the researchers would state that there is no statistically significant difference in plaque accumulation between the two conditions. Let's look at one more possible outcome. Suppose that the researchers find a mean difference at this point along the distribution. The p-value for the test is 0.03, the area from the mean difference through the upper tail. A p-value of 0.03 means that there's only a 3% chance of getting such results when the null hypothesis is true. The p-value is less than alpha, so the researchers reject the null hypothesis. These results are statistically significant. Here's an easy way to remember how to interpret p-values. If the p-value is low, that is, less than alpha, the null must go. Otherwise, it stays. The researchers conclude that the mean Plaque scores are significantly higher for the elastic module condition than for the self-ligating bracket condition. The tooth sensitivity study used a significance level of 0.05 and reported statistically significant changes in tooth shade for both treatment groups. The p-value of less than 0.001 indicates that such results could occur by chance, that is, when there is no real effect of bleaching on tooth shade, less than once out of every 1,000 times if the study were repeated. Based on the small p-value, the researchers concluded that these were real differences. They did not find any differences between the groups for either absolute risk or intensity of tooth sensitivity. The p-value for tooth sensitivity is very large. The researchers do not report an exact p-value for the intensity results, only that p is greater than 0.05, the significance level. To summarize, the researchers formulate their hypotheses and set the significance level. Then they collect data and run a statistical analysis. The p-value is determined directly from the test result. The researchers then compare the p-value to their predetermined significance level and make a decision. If the p-value is smaller than the significance level, they reject the null hypothesis and conclude that there is a significant difference or effect. If the p-value is greater than alpha, they do not reject the null hypothesis and conclude that there is no significant difference or effect. The significance level and p-value are probabilities or areas under the distribution that represents results when the null hypothesis is true. The significance level is set in advance by the researcher, whereas the p-value is determined strictly by the result of the statistical test and is therefore directly tied to the data.